Welcome to part 8, Knowing Your Aircraft. We're going to start by going into flight controls. So, flight controls can be broken down into two main groups. It's going to be your primary and your secondary. Your primary traditionally consists of ailerons, elevator, and rudder. Your ailerons control your roll of the aircraft, which is side to side. As you move the wings, as you move the stick, the wings will move. Next is going to be your elevator. So as you pull the stick back or push the stick forward, the nose is going to move up or the nose will move down. And lastly, your rudder controls your yaw. So this is going to be movement of the nose from right to left. Secondary flight controls. This is going to be your flaps. What do these do? Well, these are devices that create lift. So as you pull your flaps, you can now go at a slower speed and still not stall the aircraft because you are now generating more lift. We will get into another time as to why those generate more lift, but what you need to know for now is just that they generate more lift. They're considered a secondary flight control. And lastly, it's going to be trim as a secondary flight control. Now, what does trim do? Well, trim alleviates the need to use the main controls. So your main controls are going to be your stick and your rudder, or your yoke and your rudder. With trim, it alleviates your need to do that. On our aircraft, we only have pitch trim or elevator trim. That elevator trim, if you push up on the trim, it pushes the nose down, and if you push down on the trim button, it goes up. The trim is an electronically motor-driven trim. So what does that mean for us? That means that we just have a little thing that we flick back and forth, as compared to a more traditional aircraft where it's a wheel that they can actually move back and forth. And that's typically cable driven. So for our flaps are actually mechanically driven by rods, and the trim is driven by a motor going back up to the primary flight controls, which on our aircraft are slightly different than the traditional ones. We have what are called flaperons, which is actually a combination of the ailerons and the flaps. So these ailerons are also rod controlled, and they are what are called differential ailerons or differential flaperons. And what does that mean? That means one side, the flaperon that goes up more than the flaperon that goes down. We don't need to get into why that is for this video, but all you need to know is that it avoids adverse yaw. It's a helpful thing, we like it. And then also, the thing with the flaps is they're also flaperons because it is a combination of ailerons and flaps. So those are going to be, as we've already talked about, push rod controlled for the ailerons and for the flaps. Also, your elevator is going to be push rod controlled, and that's going to be with the stick. Many planes that have sticks are typically usually push rod controlled on the flight controls, but you do need to refer to your POH for your specific aircraft to be certain. And then for our aircraft, our rudders, which is also common on many aircrafts, are driven by wire. So it's controlled by wires. And that's also a very common thing amongst these aircraft. So that's it for the flight controls. Moving on to the engine. What we'll talk about is the engine. So the engine, we have an acronym to help us remember it. It's right hand wing. So that's RHWNG. So what does that mean? That means it is a Rotax 912 UL that is horizontally opposed, which means the pistons sit opposed to each other. So there's two on one side of the block and two on the other side of the block. Next is water cooled, which just means liquid cooled. It is naturally aspirated as opposed to, say, turbocharging, which is a forced air induction system that kind of compresses the air so that you're getting more power out of each explosion when it comes to piston movement. Another time we'll have to go into the 4 strokes of our engine, but for today, all you need to know is that it's naturally aspirated, which means that there's no forced air induction. It just naturally, it sucks in the natural air pressure from outside and then creates an explosion from that. And lastly is that it is gear driven. So what this means is that the crankshaft does not go directly to the propeller. Why? Because Rotax runs at so much higher an RPM that it would just, the propeller would move at supersonic speeds if it was rotating at 5,500 RPM, which is what we typically fly the plane at. but it's gear driven, so it has a reduction gear on it so that the propeller isn't spinning as fast as the engine. Now let's go into the flaps. What kind of flaps do we have? Well, it's very simple. On our aircraft, there's lots of different types of flaps, but on our aircraft specifically, it's just going to be plain flaps, as opposed to, say, a slotted flap, which is going to have a gap between the wing and the flap itself, which ours does not. It's just straight back into the flap, so it's just a plain flap. Real easy. The propeller. Let's talk about what kind of propeller we have. We have an FP02-80 Pipistrel propeller. So Pipistrel is a manufacturer. FP02-80 is the make. So think of this as a Toyota Prius, right? It's going to be Toyota's a manufacturer, Prius is the actual car itself. Same kind of thing, but for a propeller. It is made of wood, it is 2 blades, and it is fixed pitch. So 2 blades, pretty self-explanatory. It's made of wood, you understand what that means. What does it mean by fixed pitch? Well, there's 2 types of propellers. There's constant speed and there's fixed pitch. Constant speed, what it does is the propeller blades will actually move in order to create a constant RPM on the aircraft, which will help with fuel efficiency and stuff like that. But when we bought this plane, when Deep Sky acquired this plane, the only kind of propeller you could have on a light sport aircraft is the fixed pitch. They have now since changed that, but at the time that was the case. Next, let's talk about the landing gear. So there's 2 types of landing gear on aircraft. You can either have tricycle gear or you can have tail wheel. So on ours, it's tricycle gear. And what that means is that the plane sits, it has 2 main landing gear and sits on a nose gear, as opposed to 2 main landing gear and sitting on a tail gear. And so for us, what we need to know is that we have 2 main and 1 nose gear, which is where the tricycle comes from. The main gear is made of spring steel, so that gives it a little bit of a bounce when we actually touch down, because if it had no bounce, you're coming in at such high speeds and with so much weight that like a brittle steel would just snap, and so we don't want that, so they use a spring steel. The nose gear itself is steerable, as opposed to in some planes you have differential braking. In one of our planes we do have differential braking, which is braking between each tire, and that's how you steer the plane, and that's generally on a free castering nose wheel. Ours is a steerable nose wheel, which means you can control the direction of the nose gear using the rudder pedals. Lastly, you need to know that the strut within the nose gear, so it's absorbing that impact, is just spring loaded. Many times you'll have, as opposed to a strut that's, say, an oleo strut, which is a nitrogen air mixture to dampen that impact, and ours just uses a spring. The last thing I want to get into here is going to be your fuel system. So the fuel system, a couple things you need to know about it. We're going to walk through the entire diagram here, but first you just need to know that the entire fuel system can hold 13.2 gallons and that 12.7 are usable. What does that mean? Well, that means that there is a 0.5 difference between the two. Where's that 0.5 coming from? When the FAA completes what's called a run-out test, so you're running until the engine shuts off, it is the fuel that is left in the lines at that point. So it's called unusable fuel because there's not enough fuel to make that fuel usable. The engine's going to shut off before you can use up that fuel. So here is our diagram here. So as you would imagine, this is the engine. I tried to draw a propeller on here to make it clear. This is the fuel tank. And in between that are a couple of lines. So it moves through this red line here. So this red line is the direction in which the fuel actually moves. So the first thing you'll see, it goes from the fuel tank, it goes down to a fuel pump. So this is an electrical fuel pump. This is the one that's actually inside the aircraft. There's a button that says fuel pump. This is the fuel pump that it's referring to, that you turn on and turn off. And there's a filter attached onto that. So it runs through that, which pushes it through, and then it gets to the shutoff valve. This is the valve inside the cabin that you turn on or off. It's a red little valve that can be pushed, like I said, on or off. If it's off, Your engine might run for a second, but then it's going to shut off because it's restricting the fuel flow. If it's on, it's going to allow it to run. The next step in the process is going to be the gascolator. The gascolator is going to be the lowest point in the fuel system. This allows us to sump the fuel, which is where we are taking a fuel jar and we are pushing it up against the gascolator to drain out at least a small amount of fuel to see if there's any debris, any water in the system. We're looking for things like that. And we want to do that before every flight so that we're not sending water into the system right as we start the engine and then run into potential engine failure on takeoff or just at any point when we're flying. Now, the last step in here is actually attached to the gearbox itself on the engine is the mechanical fuel pump. This is going to be the most powerful fuel pump that we have. And that fuel pump is running, it's connected to the gearbox, and it pushes all the fuel through. And then after it runs through the mechanical fuel pump, it comes through this green line here, which we call the return line. And that's if we didn't use up all the fuel, it runs through the return line back to the fuel tank itself. Now, you might be wondering, where is it actually going to the engine? At this point, it's going into the carburetors because our engine is carbureted. So it goes into the carburetors, which mixes the air and fuel, and then sends it into the cylinders, and that's when you get the explosion, which creates the power. This black line here is going to be your breather tube, so it has to be able to breathe. If it's sucking in the air, you need it to be able to breathe, otherwise you could create a scenario where it's going to collapse in on itself because there's suction but there's no air to actually bring into it. And that concludes part 1 of knowing your aircraft.